Hello everyone, welcome to the question number 4, reverse a linked list in groups of given size. From the topic linked list of must do coding questions in Geek for Geeks. Just have a quick look at the question and we will be discussing the approach. Before discussing the approach, I would request all the viewers to subscribe our channel, and if you have any doubts leave a comment below. If you have any extra email IDs, please subscribe with all those email IDs. And now let's go to the approach. Now coming to the approach, let's understand the question first here. And before that, please make sure to watch the question number 2. Question number 2 of the linked list playlist. Okay, of this playlist only watch the question number 2. It's a similar question except in that we're not dividing it in rows, we're reversing the whole linked list. This is just little bit alteration of the same problem. I will be still explaining here, although I request you to watch the second question and come back here once again. Okay, now coming to this question, the question is saying there is a linked list given, and this is the example of that linked list, and there is a k value given, which can be anything. In this question, the k value is 4. That means we have to divide the box in 4 values, like this one box and another box. This box is a group, okay, and every group must have 4 elements in that or 4 values in that, right? And this value should be in a reverse order. How? 4 will come here, then 2. This is the first box. This is the order, right? We have reversed this order. This is good, right? We have reversed it, and this is how it should be visible in the output. 1 will be pointing out to 8 here, right? We have to reverse the second box also. If we reverse the second box, that will be 8 7 6 5. Okay, 8 7 6 and 5 at last. So this will be the output of our question, and this is a linked list, and our new head will be starting from 4 here. This will be our new head. The starting position will be this. This will be our new head at the end of the linked list. Like at the end means after reversing the groups and rearranging the address of all those groups, then we will get the new head at this starting point of 4. Okay, now how we do that? Just have a look at this left side here. This is copied from Geek for Geeks website only. Here every time next pointer moves to the next value, then the current value is positioned to the previous value, and then similarly the next will move to the next element, current will move to the next element, and previous will move to the next element, and so on, right? If you see this group here, if this is the group here, right, this is the group here that I want to explain here in a very comfortable manner. Now take a look at this box, okay, and I will be explaining this step by step, so the all the dots will be here. But this loop is used to reverse the whole linked list, but this is the same process applicable to the groups also, except in while loop there will be another condition where the loop value, okay, we will take some variable called count, and that count should be smaller than k, right? This is another condition that we add inside the while loop. Rest is same here, okay, rest is same, and we will also include c value here, and we will update that increment. Okay, we will increment the c value at the end here. Okay, now let's continue with the first statement here. What is happening? I will be writing down those all the statements here in the right side. Okay, just have a look at the diagram that I have drawn, and I will be explaining step by step each statement inside this loop. After explaining, there is a small tricky observations. After observing those, we will definitely know how can we solve this question. Now let's start with the diagram that I want to explain here. If you can see here, right, here this point, right, this is 1 2 and 3. This is the same example. So in the initial stage, previous is initialized to none value, and next variable is also none value. This is a same explanation from the left side box of this one. So this is for a linked list, reversing a linked list. Okay, for reversing a whole linked list. Okay, now the initial stage, head and current value are at the start, the one value here, and previous and next are initialized to null value. Then in the first statement, after entering the loop, okay, after entering the loop, what is happening? It is saying next will be equal to current dot next, right? So next is here at this point is current value here, right? So current dot next means this value which is on a yellow dotted line. This is the arrow. Okay, this arrow represent the current dot next value. So what is current dot next value? Is it is pointing towards 2. So this is the address of the 2, right? This is the address of the 2. here. So that's why we are pointing the next value here. The next value was previously null. So now it is pointing towards current dot next. So the next value will shift towards the two element here. This is happening in the first line and in the second line. Okay, similarly, come to the second line. It's saying current dot next should be equal to previous. Why we are doing this? This is to change the position of the arrow, or you can say we have to change the arrow direction. Okay, we have to change the direction of the arrow. The arrow is pointing towards 2 in the first line here, but we need it in the reverse order. So for doing the reverse order, we have to change the address of that particular element. So for changing that, we're using here current dot next should be equal to previous, right? Current was earlier, where earlier current was at the position of 1. So current dot next is pointing towards 2. So now we are saying current dot next shouldn't point towards 2 and should point towards the previous value or previous variable which has a value of null. So now that current dot next is pointing towards this previous variable which is null statement. So this arrow you see is this is the current dot next of the first element. So this is the statement of the second line. Now let's go to the third line here. And in this third line, what is happening is it is saying previous equal to current value, right? Now previous was at which position in the second line? Previous was in the initial position only, where previous was equal to null. Now we already shifted current dot next to previous value. So now previous element task has been completed here. So it acted as a temporary variable for initializing another variable, which we have successfully completed in changing the direction of the arrow. Now previous work is done. Now it is moving towards a new position. So it can repeat its work again, right? Now in the third statement, the previous statement had shifted towards the current element. So current element was 1 at that time. So previous also shifted towards that current element in the third line, right? And in the fourth line, what is happening? Let's see in the fourth line. In the fourth line, current is equal to next. Okay, current is 1 here in the third line above there. So current is 1 here. Now we are saying current should be equal to the next value. So current also shifted towards the next value now. So current and next are at the same position here. Now if you look at this loop here, okay, what is happening in this loop I have explained here step by step. Now you should be able to imagine it in the second iteration what will happen. Okay, in the second iteration same thing will happen. Now I am sure you are able to imagine the next iteration what is happening. Similarly, in the second iteration, what will happen is it will go to the second position here, and the direction of this arrow will be changed in the second statement here. Direction of arrow will always change in the second statement only. In the second iteration, second statement, the direction of arrow will be changed. Next will is moving to the third element, the first line itself. Next will come in the third element box in the first line, and in second line the current dot next, which is this arrow will be shifted towards left, and after that in the third line previous will be shifted towards the current value, and in the fourth line the current value should be shifted towards the next value. So this current will move on to the third box at the last. Okay, then the one will be in reverse order null. Okay, I will write the final statement what happens in the second iteration. Okay, I will be writing here final statement after completing the second iteration. Okay, let's see what is happening. What is the final outcome in the second? Okay, 1 2 and 3, and I won't be naming any variables here. I'm only going to show you the list direction what is here. This one will be like this, which will point towards null value here, and similarly second direction will be shifted here. Okay, second will be shifted in the second iteration, and third will be remaining. Now you decide where this variable have been shifted to which position. Okay, and in the third iteration, right, in the third iteration everything will be completed, and this is how we reverse the linked list. So we are reversing this in a linked list, right? We're reversing the whole linked list. Now let us take some observations from this. Okay, let us take some observations. Okay. Coming to the observation, the most important thing is the head pointer. As you can see, the head pointer is outside of the loop. So right at the outside of the loop, we are able to replace it. Okay, we are able to say the head element should start from the third variable. After completing the whole reversing the array, the head element we are replacing it with the final value, right? We're able to do it in the whole linked list. But what in the group, right? In the groups also we will face same problem. like this one, we have reversed this 42221. But after reversing this, okay, after reversing this, the one is ahead here at the initial stage, right? One is ahead of this linked list given here. Okay, one is ahead here because it is a starting value. So one is ahead. Now, if I say head dot next, which will point towards a null value. After reversing only this box, okay, don't consider the right side 5, 6, 7, 8 box. We have to reverse the first box. Okay, after reversing the first box, now if we say head dot next, that will be obviously pointing towards a null value. But we want this pointer towards the next value. Okay, next reverse order of the value. So next reverse of the order value is 8765. Now we want this arrow position towards this 8 variable. How will we do that? We will be using the recursion approach here. Okay, now let us see the recursion approach. Let's understand a recursion approach, right? I hope you have understood how we are reversing this whole linked list. Now we're using a recursion approach based on the explanation how we reverse. Okay, now let us look into the recursion approach here. I'm erasing the below statement here. Okay, let's write the reverse order, which is 4, 2, 2, and 1. So this is the reverse order. And after reversing, 4 will point towards 2, 2 will point towards 2, and 2 will point towards 1. And 1 will point towards a none value here. Okay, none value. So this is the first observation that we have in mind. 1 is pointing towards the none value, which we don't want that to happen. So this is the first group. This is the first group. Now let's take second group on the right side, and in the second group we have 8, 5, 6, 7, 8, and we'll also reverse that 8, 7, 6, and 5. Okay, 5 will also point towards the none element here. But in the second case, there is no problem. We want that last element to point towards the none value only. So it is fine. For the last group, it is absolutely fine to have a none value. But at the earlier groups, okay, earlier groups mean the before the groups of the last group, before the last group, whatever groups are there at the earlier, they should point towards the next value of the next group, right? Next value of the next group is this one, 8. So we want this arrow pointing towards this 8 value. Now how will we do that in recursion approach? In recursion approach, we're using this same approach in the recursion also. We're using this while loop, and but we will be adding one more statement after the while loop, which will be used for recursion. Okay, in that we will be checking the next value. So this is the next value, right? Current dot next. So current dot next is none here, which we are saying. So in that next statement, we say if current dot next is not none. If it is not none, then we use recursion. Then it will call this function itself, and we will be giving the next address of the pointer. Now let's see 4221 have been completed using the reverse order, right? Okay, so this for using the reverse we use this linked list. So in this linked list, the next statement here is the current dot next. It will copy this address. Okay, it will copy this address before reversing. Before reversing, it should copy, right? It will be reversed at the last point only. First it copied this address, then we change the direction of the arrow. Okay, then we change the direction of arrow. That's why 4221 we got that. We have the next address, which is 5, which is not none. So if it is not none, then we have to use recursion. The recursion, similarly, it will reverse the whole linked list of the next group, which is 8, 7, 6, 5, and again it will check if there is a next element, next dot next, right? Current dot next, is it none? No, it is not none. So in the second iteration, it will stop the recursion. After stopping the recursion, we will get the value in return. What value? We will get the value of the previous element. So what could be the previous element in this linked list after reversing? That will be 8 here. It will also be equal to head, right? Now here reversing this head here. Now we got the head which was 8 here. So we will be returning that to head dot next element. Okay, I told you there is a function that is used for recursion, and we will be seeing the code soon. Okay, we'll see the code soon, but just understand there is a function. In that function we initialize head dot next will be equal to the return of the function. So whatever the function is there, you can say I'm just giving an example like ab. So this is a ab function. This is ab function. Just for example, it may be different in code. AB function. the AB function will get the value of the previous group, right? In the second recursion will end from the inside. Okay, this is the second recursion, this is the first recursion. Second recursion will end. After that, it will give us the value of the previous element. Okay, previous element in that group is 8. We'll get the value of 8 here, or address of the 8, you can say. Address of the 8 we get, address of 8 we get. And now I told that after reversing this linked list, head dot next was pointing towards what value? None value. So this head dot next will be now reinitialized after the second recursion has been completed. We will get the value 8 and that will be initialized to the head dot next. Head was 1 initially. Now head dot next, this is head, but dot next is none here. So we are eliminating this none value and initializing with the address of 8. Now the direction of the arrow will be changed. Now it will be pointing towards the 8th element value here. Okay, in the second in the second recursion, or you can say the outer recursion, the inner recursion will be giving the value of address of 8 that will be used to reinitialize, and we get the reverse order of that. That is 8 here. Now we have initially the arrow has been connected. Now after that statement has ended, now we will return the previous value, and previous value for this group is 4. Okay, remember this is the output that I am showing. Okay, before output, this is the linked list which we are going through. Okay, in that linked list, the last element will always be in the previous address. Okay, previous address will be pointing towards this last value of 4. So right, so that previous will also be head here. So we are returning the previous address value to the function. So this will be treated as a new head. Now if you connect this linked list, you can see 4 is connected to 2 is connected to 1, and 1 is connected to 8, 7, 6, 5, and none. So this is how the recursion approach works. Now let's get into the coding section. Then it will be much clearer to you what is happening in recursion after knowing the code. If you haven't understood till now, watch the video again. And also please check the code once. Okay, after checking the code, you can re-watch this video. You will have a much better understanding. Now let's go to the coding part. Now we are inside the coding section here. As you can see, head is equal to none. We return none. If there is no address for a head, then that means there is no linked list, so we're returning. And now current is equal to head. We're copying the head in another variable called current here. Now previous is initially none here. Okay, count is equal to 0 here, and I told you we have to add one condition, so it will divide itself in groups, so it will not repeat more than 4 times. In this case, it will run 4 times, loop will run 4 times here. After running 4 times, it will be in a reverse order, 4 2 2 2 1. Okay, that's what it's doing. And now after that, the next is not none, right? This condition will be satisfied. Why it will be satisfied? Because here 4 dot next, right? 4 here 4 current dot next is equal to current dot next. So current dot next of 4 is pointing towards the address of 5 here, right? So it is not none, it is pointing to some address, right? That's why this condition will be satisfied, and it will go to another function. That will be the same function. It will call itself. After calling itself, it will rearrange this to 8765. Okay. Now after rearranging, there is a broken link here. We have separated this, but we haven't connected this arrow to the next element, right? Now inside the second recursion, or the innermost recursion, which we have separated like 8765. In this you can see there is a return function also. Okay, in the second recursion or the inner recursion, this previous value will be, or previous address will be returned to the outer recursion value. So the previous is 8 in the inner recursion. This 8 address is the previous address for the inner recursion. So this will be returned to this first outer recursion. After returning that, we are initializing that head dot next should be equal to address of 8. Okay, in that way now we are able to connect that link which was separated earlier. Okay, this head dot next is connecting one group to another group by removing the none value and initializing with next previous element. Okay, so that is what happening in this recursion. And finally, when all the elements have been connected, in the outer recursion or the first group recursion, you can say, or the outermost recursion which happened at the earliest stage. Now after the recursion, now there is no more self recursion here. Self recursion has been ended. Okay, after ending that, in the outermost recursion part, we are returning the previous element. So previous address for the outermost loop, I mean outermost recursion is 4 here. So now we return the address of 4. Now you can count now 4221876. Everything is connected, and this will be the output for our solution. I hope you have understood this question. If you have still not understood this question, I want you to rewatch this video. Right? If you have any doubt, still facing some problem, I like you to comment down what is the problem you're facing, and I will be responding, and I will give you the response as soon as possible. Okay. I hope you have understood. With this, I end my lecture and thank you for watching till the end. Let's meet in the another question.